All right, so I'm back talking to you about section 12.4 now. We're in the statistics chapter, the last chapter of your course. So yay for that, right? So we're finishing up. So if you'll follow along with me on your note packet, again, we're talking about section 12.4, which is measures of dispersion. So a little different than what we talked about in the last section. The last section, remember, was averages, measures of central tendency. So this talks about measures of how much the data is dispersed or the spread of the data. If I wrote the numbers 1, 1, 1, 1, 1, 1, we would say it's not very dispersed, right? It's there's no variation in the data. There's no spread of the data. If I write the numbers 1, 5, 50, 900, that's a big spread of the data. That's very dispersed data. So this would have a large standard deviation, a large deviation of the mean or measure of dispersion, and this would have actually no dispersion at all. So it would have small, we would say. So that's what dispersion means. Instead of finding their averages, we're asking how much is the data spread or dispersed. And we have a big O formula for figuring that out. So there's actually two measures of dispersion. There's one that has a very simple formula and then the one that has a more complicated formula. So again, two measures, and then what we're going to do on this video is just talk through those two formulas. Before we do though, I always want to make sure I say all the pertinent kind of intro stuff, and I have that on your note packet here. It says measures of dispersion are used to indicate the spread or the variability of the data. The range and the standard deviation, that's our two measures we're doing here, is what we'll study in this section. The variability of the data is important for quality control. For example, when you buy a box of cornflakes at the supermarket, you expect it to have the same amount of volume that's stated on the box, right? So however many ounces of cornflakes you think you're supposed to be buying, you expect that to be in the box. So you would be displeased if you open the box that was only half full. If a sample of 50 boxes were taken, the volume measured, you would hope for a low standard deviation, maybe even 0, but there would probably a little spread of the data. But a quality control person maybe is taking those corn flakes, maybe taking a sampling, maybe every 1,000th box or every 100th box off the line, and then measuring that, making sure there's a quality control within that there's a small standard deviation, that you're getting what you expect. When the numbers stay near the mean, this tells us there's a very small amount of variation or variability. The range is simply, that's the simple one, the range is simply the largest value minus the smallest value. This measure is useful for examples such as if you want to know the range of a swimming pool. You would not necessarily want to know the average depth. So say you're swimming in the lake and here it's like a half of a foot or six inches, and then over here it's a 10 foot drop, in the water. So you wouldn't want to know the average. That wouldn't give you the information you need. Or even of a swimming pool, if it's a sloping swimming pool, you want to know, what is the range? What's the lowest point? What's the highest point? What's the range in the values? So if you can't swim, the average depth will do you no good. If say the average depth is 2 foot and you're like, well, I can stand in 2 foot of water. But no, that would not be good if they're telling you the average. What you need is to know the range. You need to know the shallowest depth and the deepest spot. And so the range, say it's 6 foot and 1 foot like I have in your packet. If you had a spot in your pool that's 1 foot deep, and then the other end is 6 foot deep. So you got 1 foot, 6 foot, the smallest measure to the largest measure. We would say the range is 5 foot. There's a range of 5 in that data. All right. Okay, so let's talk about these two formulas. So again, range just means the largest number minus the smallest number. Standard deviation, on the other hand, is an average of the spread of data. What is the average deviation from the mean, basically? The average spread of the data. So it is this beautiful formula here. Looks kind of complicated, but let's work through it. And this is the sample standard deviation. If you remember earlier in the book, we talked about how we usually would take a sample. That would be more common. So this is a sample standard deviation formula. And we use small s to mean standard deviation, short for SD or standard deviation. It is the square root of the sum. Remember how epsilon E stands for summing things. So it's the sum of every piece of data, subtract the mean, take that answer, square it, and then the sum of all of those values. So order of operations is going on here. You do what's in the parenthesis first, the innermost parenthesis. You take each number minus its mean, and we'll write this down just a minute. It's on the next page. Each number minus the mean, you'll square each one of those answers, so it's a repeated calculation. You do all those calculations, then add them together. Sum all of these calculations. You get that answer. Then you divide that answer by n minus 1. Now, if you remember from the last video, n means how many numbers. If you've got 10 pieces of data, n is 10. So it's however many numbers you're dealing with minus 1. You subtract 1 before you divide. So subtract 1, that divided by that, get that answer. Then the last thing you do is that final calculation of square root of the final answer. Okay. All of that is listed on the next page in a step-by-step. It's an 8-step process. So if you look at that with me, if you need to write that down in the video, I'll read it off to you as well. Step number 1, before you're going to be able to do this innermost parenthesis, you're going to have to figure out what the mean is. Sometimes that number is just given to you, especially when we get to the next section. They won't hassle you with finding your own mean. But right now, in some of our problems here, we'll have to find our mean first, which we learned in the last section. So step 1, figure out what the mean of your data is by adding up all the numbers and dividing by how many numbers are present. Get that mean average. Step 2, if you want to, we recommend you make a chart to help you organize yourself. Make a chart with the data, the piece of data, and then this step, and then this step squared. So you'll have, those 3 columns to help you do your calculation. Then 3, list the data in the data column. Then do your subtracting part. Then do your squaring part. So it's, like I said earlier, it's order of operations. You do this first, so you need to figure out what that is. Then you write your number, subtract it from the mean, and then in the 3rd column, write what that would be squared. Then on step 6, you're going to add all those together. You're going to sum it. Then on step 7, you're going to divide what you got there by the number of pieces of data minus 1. Count up how many pieces of data. If there was 10 pieces, you're going to divide by 9, right? You're going to divide by 1 less than what you see. Then step 8, the last step, square root that final answer. All right, so here we go. We've got 4 examples. Well, we really can't do that second example unless I knew all of your ages. If I had you here in person, I was going to take a survey of some of the ages of our class and figure out if there's a large spread of data, if there's some extreme, if we're all about the same, what's the spread of data in ages. So we won't be able to do that so much here. Maybe sometime I'll do something online where we can share in that. But anyway, we'll do the other 3 problems together. So number 1, we're given these numbers to practice with. It says find the range and standard deviation. So this will make you appreciate the range is so nice. You take the largest number, 21, minus the smallest number in that list is 13. 21 minus 13, the range is 8. So there's that answer. Now you're going to have to work a lot harder for the second answer though. So, and again, remember, range is different than mid-range. Mid-range was an average in the last section. In this chapter, we do spread of the data. What's the largest number minus the smallest number is the spread of the range of values. So there's 8 in our spread. Okay, then the hard one. Standard deviation. So what you got to do first is figure out the mean. Find the mean. So we're going to add all those together. 1, 2, 3, 4, 5, 6, and then divide by 6. So find your mean there and pause the video if you need to. If you're practicing alone, you should get 96 divided by 6, which is 16. So the mean, scooch over there. The mean is 16. Okay, then I'm going to need that information to make my columns that I mentioned. So across the columns, you can make 3 columns. I think I made that too big. But we're going to write out our data. which is the 15, the 15, the 19, the 21, the 13, and the 13. Each piece of data, that's our x. And then our data minus the mean will be 15 minus, what does that mean? 16, which equals, I need to make my column a little further over, don't I? Which equals -1. And then we're going to take that squared. So each number, subtract the mean, equals, if it's negative, you're going to square it as if it were in a parenthesis. So the negative is squared, making it +1. Then 15 minus 16, we already did that, it's 1. 19 minus 16 is 3. Then we square it, which is 9. 21 minus 16 is 5. Squared is 25. 13 minus 16 is -3. Again, the negative gets squared, so it's always a positive something down here. And then here it is again. All right, so that's my calculation, the big bunch of it. Especially if you got a lot more numbers, it's even more tedious. So then we add all those up. So the next thing is sum all of your answers. So we're adding that, 1 plus 1 plus 9 plus 25 plus 9 plus 9. See, I wrote that down somewhere. That came out to be 54. So this answer, the sum of all of those calculations is 54 for us. Then we divide that by n minus 1. So we have 1, 2, 3, 4, 5, 6 numbers. So n equals 6. So it's 6 minus 1 or 5. So 54 divided by 5 is 10.8. We're not done though because the last step is square root. So square root that 10.8. So use your square root of that 10.8 value. And I might have rounded it a little bit, so keep it as exact as you can. But that should come out to be 3.286, and then your directions should tell you what place value to round to. If I rounded it to the nearest tenth, it would round up to 3.3 in that case. So 3.3 to the nearest tenth, it'd be 3.29 to the nearest hundredth, so do watch your rounding on that. All right, let's try it again. Okay, number 2, I said we'll have to skip that for now, although I'm curious what it would be. Number 3, we're going to do these teacher salaries. We talked about these teacher salaries in a previous video, some sample values. I don't know how accurate they are to current times, so don't judge it too hard on that. But we've got all these teacher salaries, or it could represent anything, that doesn't matter, but sometimes it makes it more fun to do the problem if you feel like it applies to something you might be interested in. But you've got all these values given, and the first thing we have to do is figure out our mean. So you're going to add all those numbers together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 numbers, and I didn't write that down again. Whatever that would be, though, and I know y'all probably are more meticulous to add that together than I am. I'm kind of sloppy sometimes. But add all that together, divide by 12. I found the mean to be, I didn't write that down. I just did the final calculation there. So anyway, I did just write down your final answer for you to work this. Oh, I did write it down. Get with it here, right? I found it. The mean was $29,571.67, the average mean of these salaries. Then, after you figure that out, it's when you do your next calculations, the big calculations, where you take every number, every one of those numbers I listed, minus this mean I found, and square that answer, then divide it by n minus 1. N in this case is 12, so 12 minus 1, you're going to divide by 11. Then the last thing you do is square root that final answer. And the answer to number 3 should be 6271.65. And then number 4, The question, oh, we're not going to calculate number 4 actually. It just says, look at that. Which one do you think would have a larger standard deviation? Without actually calculating, remember deviations, how far they spread from each other. So the first one seems to vary a little more than the second one. The second one just has numbers 21, 22, 23, and 24, and a couple of those repeated. The other one varies much more with a 15 to 26 spread. So I would say the first one varies more, and if I calculated it, it would have a higher standard deviation. All right, feel free to contact me if you want to work one of these problems together. I love to crunch these numbers, and be in touch if you need me.